All right, this is part 2 of adding fractions using the jealousy method. So here's another example, 3/20ths plus 5/28ths and 1/30th. Now remember, the jealousy method means the denominators are jealous of each other. They all want to have the same factors, sort of like keeping up with the Joneses. So we always factor the denominators and leave a little extra space for more factors. The numerators you do not factor. So we have 2 times 2 times 5, that's the factors for 20, plus, now for 28, that's 2 times 2 times 7. Remember, you do the prime factorization by using a factor tree or any other method. And for 30, let's see, that's 5 times 6, so that's 2 times 3 times 5. Looks like I might run out of room over there. Okay, so I start with the first denominator, 2 times 2 times 5, and I look over at each denominator and see if it has something I don't have, and if so, I want one too. So I'm missing a 7, so I want to multiply top and bottom by 7, so at least I've got whatever the second denominator has. And then I look over to the other denominator. I've got 2 times 3 times 5. Well, I've got a 2, I've got the 5, I don't have a 3, so I also need a 3. So this denominator I now have is the least common denominator right here. That's the least common denominator. All right, so I make sure in all of my other denominators I also get the same 5 factors. So for the second denominator I have 3 factors, a 2, 2, and a 7. What am I missing? A 3 and a 5. Now, to save space, 3 times 5 is just 15, so I'm just going to write 15. All right. Oops, and I forgot to put the 1 up here. That's always there. All right, now I look at the third fraction. For its denominator, I have a 2, a 3, and a 5. I need to have 2 2's, right? And I also need a 7. So I'm missing a 2 and a 7. So that means I need to multiply the top and bottom by whatever 2 times 7 is, which is 14. So convince yourself that all the denominators are now the same. They all have really the factors in prime factored form, 2 times 2 times 5 times 7 times 3. So we can leave that in factored form or multiply it out. I'm going to leave it in factored form for right now, just in case something might cancel later. So I have 2 times 2 times 5 times 7 times 3. All right, now what do I have in the numerator for the first fraction? I got 3 times 7 times 3, so you need to multiply those 3 numbers together. I'm going to think of that as 9 times 7, or 63. For the second fraction, I have 5 times 15, that's 75, and 14. So I need to add those 3 numbers together, so we can go over here on the side, and we're going to add 63, 75, and 14, 12, carry the 1, 14, 15. I got 152. Hopefully I did that correct. So I've got 152. Now, this is the reason I kept this in factored form. I'm going to see, in my head, I'm going to think about it. Are any of these factors going to go into 152? Well, certainly 2 goes into it. 5's not going to go into it. 7's not going to go into it. 3 doesn't go into it. But I know at least I could divide by 2. Okay? So I'm going to write that as 2 times whatever's left here. That's 10 times, and actually, I think I'll just leave everything factored for now. 2 times 2 times 5 times 7 times 3. And we go. So what do we have here? Now, I can prime factor 152, or I can just cancel 2 into it. I'm going to go ahead and just do a little prime factorization here for 152. 2 goes into it. Let's see, 76 times. And then 2 goes into that, 38 times. And then 2 goes into that, 19. So I see that there are going to be 2 factors of 2 at the numerator that'll cancel with those two twos. All right, so I'm going to simply write out the prime factorization so you could see it. 2 times 2 times 2 times 19 over 2 times 2 times 5 times 7 times 3. And then I can see I can cancel out factors of 2 in numerator and denominator. I finally get 2 times 19 is 38 over, let's see, what's this going to be? 21 times 5 or 35 times 3, however you want to do it. I think that's going to be 105. And that should be my reduced answer. Okay, so I could have multiplied out this denominator, 2 times 2 times 5 times 7 times 3, whatever that happened to be. Let's see, that's 21 times 2 is 42 times, it's going to be 420. So if you had done that, you just keep note, you could have had 152 over 420, and then you would have to reduce this 152 over 420. If you reduce that, you would eventually get to 38 over 145 as well. I just thought it was easier to leave in factored form and then just cancel. That's up to you though. So that last one was a pretty difficult problem, large numbers, etc. Let's just do one more problem where we have subtraction and addition. Keep in mind, when you go left to right, you first have to subtract the 1/6 and then you add the 5/8. Okay? But you could just put them all over one denominator. Just make sure the minus sign only goes in front of the second fraction. So if I prime factor the denominators, I have 2 times 2 for the first fraction. I have 2 times 3, that's the factored form of the second fraction, and 2 times 2 times 2 for the third fraction. So I look over, the first denominator looks over and see if it's missing anything. Well, looks over to the second fraction, it doesn't have a 3, so it takes on a 3. And it also looks over at the third fraction's denominator. It's got 3 factors of 2, so it needs another 2. So instead of putting times 3 times 2 at the top, I'm just going to multiply those together right now. That's going to be 3 times 6. Just giving you various ways to save your writing. Okay, now that's the least common denominator, right? Whatever I got in that first fraction. So there's going to be 4 factors in prime factored form for all the denominators. So for the second fraction, I have a 2 times 3. I'm missing a 2 times 2, which is a 4. And for the last denominator, I've got 3 factors of 2. It's missing the 3. For some reason, I forgot to write that 5 up there. So it's missing a 3, so I multiply the top and bottom by 3. So this gives me 18. So I'm just going to deal with the numerators. 18, and this was minus. Got to be careful we copy it correctly. Minus 4 and plus the 15. And I'm just going to leave the nothing in the denominator for a second and do my arithmetic on top. I've got 18 minus 4 is 14 plus 15. That's going to be 29. Well, since it's prime, it's not going to cancel with anything in the denominator anyway. So I'm going to multiply the denominator out. It doesn't matter which of these 3 denominators you look at, they're all the same thing. It's going to be 24ths. So my answer is 29 24ths, which does not reduce, or 1 and 5 24ths. Okay, so it's just a couple more examples using the jealousy method. Keep in mind, lots of different ways that you might go about adding and subtracting fractions, employing different kinds of methods for figuring out the least common denominator, etc. This is just one method that you might like to use.